On the board there, you can see I've got x squared plus 6x plus 1 is equal to 0. And we want to use the null factor law, but there are no numbers that I can multiply together to give me 1 that will add together to give me 6. Well, there are, but no simple numbers, right? So factorising is not going to work at this point. So what we're going to do is we're going to implement a different method to factorise it relatively quickly. It's going to be the second tier of 3 ways of solving, with the third way being the quadratic formula. Sorry? Oh, quadratic formula. Okay, so couple of quick things here. It's a bit of a cheat, but let's just say Maddie had $10, and then I gave her $5, but then I took away $5 from Maddie. How much money does Maddie have? $10. Okay, that's pretty obvious, right? But if I apply it to algebra, it's a common technique that we use to add and subtract something, because we would agree that although the value hasn't changed, the concept of what's happened has changed with an add and a take. Okay? So how does that apply to the problem on the right-hand side? If we look, left-hand side, sorry, if we look at the first 2 terms, x squared plus 6x, if I wanted to, I could add 5 and then subtract 5 and then put my plus 1, and I haven't changed the value of that left-hand side, agreed? I could also go, this is x squared plus 6x plus 5 minus 4. I just put those together there. That would be equivalent, wouldn't it? Okay, so we can add and subtract and change what it looks like without changing the value. Okay, and this is what we're going to do over a series of steps. We are going to change what it looks like without changing its value in a very deliberate way, which allows us to easily solve the equation. If you look at those first 2 terms, if I pull those out, excuse me, x squared plus 6x, they are effectively the first 2 terms of a trinomial. So sorry. The first 2 terms of a trinomial, which we can then complete to make a perfect square. Okay? And this is why you needed to know those rules really well. So the rule for a perfect square is a squared plus 2ab plus b squared equals a plus b all squared. Yes, yes, yes? So the shape of this middle term here is what we're going to aim for here. If I split that 6x up a little bit so it looks like this, it would be like x squared plus 2 times 3, if you like, times x. So we've definitely got a 2 there. We've definitely got a 3 there, because 2 times 3 is 6. And then we've got the x, which is reflected with the x squared here. Good so far? Okay, why do it? Well, if I've now got the 2 middle terms there, the 6x, sorry, is the middle term of a completing the square, then I can add 9 to it to finish off that square. 9, because 9 is 3 squared, which is what that links to. What do you think? But I can't just add 9, right? Can't just add 9. If I'm going to add 9 to an expression, I've increased its result by 9. Just like if I gave Maddie $9, she would be $9 richer. So to bring her back to what she had, what did we do? We subtracted straight away. Yeah. And we've got to do the same thing with this as well. So as long as I subtract, I'm okay to go. So going back to the original problem then, x squared plus 6x plus 1 is equal to 0. I complete the square by adding what I need to add in. I've stuffed up somewhere with my example. Then I no, I haven't. Then I can factorize this bit. Thank you. I knew I'd done something wrong. Thank you. I can complete it. So I can then take away 9 straight away. This first bit gets factorized to x plus 3 all squared, and then I've got a minus 8 on the end. Okay? Now, this is something that you have been solving recently. I add 8 to both sides. Square root both sides. And then subtract 3 from both sides. Now, what we are left with is two solutions, negative 3 plus root 8 and negative 3 minus root 8. They're not nice and neat solutions, but they are nevertheless solutions. If we knew what the square root of 8 was, it's about 1.6, I think. Then we know that our solutions are roughly minus 4.6 and roughly minus 1.4, something like that. Okay, so we can get some reasonable solutions from it. So it's called completing the square. Now, I have a particular method that I use to do this process rather than trying to overthink it too much. Are you happy if I show you that? What I've just showed you, though, you could do, which is basically look at the term with the x in it, split it into something like this, and then figure it out from there. But this is basically how I would do it. Same problem, I think. I go in a one shot. I look at the middle number and I halve it. That's bad if I write that. Halve the number, which is 3. I look at the sign here and I see that it's plus. And so that I go straight into x plus 3, halve it, squared, always minus 3 squared. So can you see I've kind of matched those two up like that? And then the plus 1 on the end. And you can see with a next step, I'll have minus 8 equals 0, and then I can solve it from there. So to me, that's a pretty efficient method, but you need to understand why it's working. The halving it is because of what I said before. If I have x squared minus 6x plus 1 equals 0, then I'll do the same process, x minus 3 all squared. So a minus here instead of a plus. Then what? It's not minus negative 3. Well, technically I suppose it is, but no, it's just minus 3 squared again. I paused there, of course, because I was expecting people to think that you would add it like a reversing operation. Now, the reason why is if I do this the manual way that I did before, the older way, like so. So when I split this, I'll get 2 times 3x. That's fine, with the 3 being there. But to complete the square, remember the square when completed is always plus when I finish it off. In other words, a minus b all squared is equal to a squared minus 2ab, but then plus b squared, because you're squaring a negative number to get a positive, okay? So that's probably the biggest trap for young players. You're always subtracting after you've finished off the brackety bits, always, regardless of what's happening inside the bracket. So that will give us x minus 3 all squared minus 9 plus 1. That will give me x minus 3 all squared minus 8 is equal to 0. Just going down the page here. That will be x minus x minus 3 all squared is equal to 8. X minus 3 equals the plus or minus root 8. Did we do rationalising surds, by the way? You need to know it. If you did in grade 9 Maths Extended, we have definitely done it. Who's done 9 Maths Extended? Yeah, so this will be a quick reminder for the rest of you. It might be the first time you've seen it. So really quickly, the square root of 8, if you can find a factor of a number which is a perfect square, you can split that number into that perfect square multiplied by whatever's left over. And because that's a perfect square, the square root of 4 is 2, right? So that's equal to plus or minus 2 root 2. So you should always rationalise your surds, your square roots. So that becomes x is equal to 3 plus or minus 2 root 2. Okie dokie. All right. So I don't remember what root 8 is, but I do remember that root 2 is about 1.4. And so 2 times 1.4 is about 1.8. So it's going to be 3 plus 1.8. 2.8, sorry. 3 plus 2.8 or 3 minus 2.8 is an approximate answer. What do you think? Okay, so they do get harder, but let me just start by giving you a problem just to try right now, and we can troubleshoot it together. Then I'll give you some problems to do from the textbook. So let's go for, I'm going to make it one step harder because we're doing it together. I think we'll be okay. Now, you might, no, I won't say anything. Hang on. Yeah. I'm going to give you a chance to get ahead, then I'm going to pick on people. Just remember, when I pick on you, I don't expect you to get it right. I'm happy if you do. I'm glad if you do. But I don't expect you to get it right. I just expect you to participate, and that's the main thing. I think sometimes we learn as much by our mistakes as we do by getting it right all the time, right? Okay, stop. Miles, what was your first step? To go, what the hell? Ah, you did that? Okay. So to get divide 8x by 2 to find that middle term is not a bad thing to do, except that you're right. Having the 2 in front of the x squared does change the dynamics a bit. Eve, what about you? Yes, thank you. Factorize out first. As an always first step, always look to see whether you can factorize. Okay? So in this case, we can factorize out to 2, or to put it a different way, like I said before, let's just divide both sides by 2. So we divide by 2, and that gets us x squared plus 4x plus 2 is equal to 0. And now we can use the process. Yep. Okay, so I'll give you a chance to keep going for a bit. that minus there. Does that make sense? And then subtract 2 squared straight away. And then add the 2 after that, if that kind of makes sense. So it's always the sign here, or the sign here will always go in the brackets, and then you immediately subtract whatever the number, like you got 2 there. Yes.
That one.
That's fine.
That one.
And then the plus 2 just goes on the end. Perfect. Yep, perfect. Okay. So you should have got x plus 2 all squared minus 2 squared plus 2 as your next step. Yep. Alrighty. So that gives us x plus 2 all squared minus 4 plus 2. Now, I wouldn't even do that step. I'm not even going to insult your intelligence by leaving that step there. So that's, now be careful. This is subtract 2 squared. It's not minus 2 all squared, which gives you positive 4. This is subtract 2 squared. So we've got minus 4 plus 2 is minus 2. X plus 2 all squared minus 2 is equal to 0. X plus 2, lots of 2's here, isn't there, is equal to 2. X plus 2 equals root 2 plus or minus. And so x is equal to negative 2 plus or minus root 2. Two solutions. Yeah. Yes. So I subtract, so I divide 4 by 2. That gives me my 2. So that gives me that number there. So if I expanded that, that will give me x squared plus 4x plus 4. So that's why I'm subtracting the 4 squared, the 2 squared there. So that's where the 4 is, the squaring of the 2. Minus 2 squared is minus 4. Minus 2 squared is minus 4 plus 2 is minus 2. Or have I misunderstood what you're asking? Every time you ask a question and you chase me down for clarity, it helps everyone. So if I haven't explained it clearly, say now. Okay. So we halve that the term with the x in it to get the 2 and so on. Any other questions? So we're not, well, that was my way of explaining what to do. So here you can see the 6x has been split into 3x plus 3x, I guess, but that's otherwise known as 2 multiplied by 3x. So the splitting into 2 is effectively this process here. And because it's a perfect square, we want to split it into the same number. Now, I know that there is a technique for solving something like x squared plus 5x minus 6. And you go, well, that's x squared minus 3x minus 2x minus 6. So that is a technique for splitting using grouping in terms. And then factoring out the x minus 3. So that is a technique where we split the middle term, then use grouping in factorize by grouping in order to factorize. I did not teach you that method, but of course you're in grade 11. You know, chances are you've come across a teacher that's done it. Absolutely legitimate way of doing it. The only issue is that sometimes getting that split is challenging when there's something in front like that, because then you have to consider how to split the 4x squared as well, kind of thing, which is where the box method actually ends up being a lot more, a lot easier. Does that answer your question? That's what the splitting is. So yeah, that's effectively what we're doing in the perfect square thing. We're doing a split, but with a perfect square, the split is always in half, which is where the half times goes. Iris? Oh, that's not a good example, is it? That's what you get when your teacher's thinking off the cuff. Ta-da! That would work now, right? -3 times -2 is +6. And -3 minus 2 is -5. Thanks, Iris. Miles. In this part here, because because the last term in a perfect square is always positive, the sign of this is kind of irrelevant in that the fact that you're subtracting means that you'd put a subtraction in here if it was there, and if you're adding them, then you're adding it there. But apart from that, you're just looking at the number. Don't worry about whether it's -3 or +3. You're just worrying about half of that number, which is 3, which you then square to get 9, which is always positive, and then you're subtracting. So you're always, I'll just zoom up now. So regardless of what's happening up here, sorry, once you've halved it, you're always just subtracting. Doesn't matter. It's just 2. It's not -2 or whatever. It's just look at the number rather than whether it says plus or minus there. After I've done this bit, so you're always subtracting because when I do the expansion, I'm always effectively adding 3 squared or 2 squared. Regardless of whether this is plus or minus, I'm always adding it. And so this bit here is the I've just added something artificially, so I'm going to subtract it straight away to make it disappear again. So you're always subtracting because you're always getting rid of that third term that you artificially introduced. Probably easier to see on that one there. I'm subtracting 9 because I added an artificial 9. Yeah. Is that making more sense? Cool. Any other questions? All right, we've got 2 minutes left, so I won't get you to do bookwork, but I will get you to do another example. Yeah, I'll try this example first. Do it really fast. On your marks, get set, go. Okay, let's see if I can chase you. Okay, who got this far? Damn it. Yeah, who got that far? Great, well done, you two. So if that's correct, I'm just conscious of time. So that's correct. If you get to that point, then note that it means there are no solutions because if I try to square root both sides, no real solutions. If I try to square root both sides, I'd be getting the square root of -1 on the right-hand side. So if it's negative on the right-hand side, no real solutions. Okie dokie. Real quick. Next lesson, I think I'll tie it back to the graphs as well. But really quickly, x squared plus 5x plus 1 equals 0. if you could just not pack up, that'd be great. I'll be really quick. It's the same process, just tedious, right? So that would be, not equal, sorry, you can only use one equal sign per line. That would be x plus 5 on 2, or 2.5 squared, minus 5 on 2 squared plus 1 equals 0. That would be x plus 5 on 2 all squared, minus 25 on 4. You okay with that? And what I do is go straight into the same denominator there. So 4 on 4. So that's x plus 5 on 2 all squared minus 21 on 4 is equal to 0. Now I can add 21 on 4 to both sides to get 21 on 4 there. Square root both sides to get x plus 5 on 2 is equal to the square root of 21 on 4 plus or minus, which is plus or minus root 21 over 2. Yeah? Or if you like, plus or minus a half root 21, because the bottom number, square root of 4, is 2, which means that x is equal to the glorious number of 5 on 2 plus or minus a half root 21. So you can do it with odd numbers in the middle, but once you're getting to the point where there are odd numbers in the middle, can I say that quadratic formula is actually more efficient, I believe, than doing it like this, because you get stuck with your fractions. Okay, I'll do harder ones on Monday, as well as giving you practice time, as well as linking it all back to graphs. Thank you, team. Have a good weekend.